A Venn diagram is a way of visualizing propositions. It's a standard tool that's often used when talking about probabilities. In this lecture, I want to talk about how we're going to move from truth tables to Venn diagrams. So here's a truth table. This is a simple truth table for disjunction. There are 2 atomic propositions, so that means there are 4 rows in this truth table. Each row of the truth table assigns truth values to these atomic propositions. So for example, in this 3rd row right here, we assign false or F to P and T to Q, or true to Q. In this row, P or Q is in fact true because at least one of the disjunctions is true. So what we want to do, what a Venn diagram allows you to do, is to visualize that proposition, the disjunction of P and Q. So the first thing we're going to do is we're going to name each row of the truth table. So I'm going to call the first row V1. So V1 is a name or picks out. It's a way of referring to this row. And V2 refers to the 2nd row, V3 to the 3rd row, and V4 to the 4th row. So it's a way of basically saying there are 4 different possible situations or truth value assignments, V1, V2, V3, and V4, and each truth value assignment corresponds to different ways that P and Q may be true or false. So to visualize P or Q, the first thing I'm going to do is I'm going to write down my 4 possibilities, V4, V2, V1, and V3. And you'll see why I'm drawing them in this kind of odd way. So again, remember, V1 corresponds to the first row of the truth table. Now, how are we going to visualize it? The first thing we want to do is we want to visualize P and Q, those 2 atomic propositions. Well, what we're going to do is to visualize P, we're going to circle all the situations that make P true. So we think of P, the proposition P, as being identified, or we're going to identify P with all the ways that P can be true. There are 2 ways that P can be true, corresponding to the first 2 rows of the truth table. And we're going to do the same thing for Q. Q can be true in 2 ways, namely corresponding to the 1st row and the 3rd row. So V1 makes Q true and V3 also makes Q true. So now we have a way of visualizing P and Q. So what part of this diagram over here, this is a Venn diagram, what part of this diagram corresponds to P or Q? Well, we're going to follow the same idea, but now instead of drawing a new proposition corresponding to P or Q, we're going to shade the regions that include the rows of the truth table that make P or Q true. In other words, we're going to shade the situations that make P or Q true. So that means we're going to shade inside of P and inside of Q, and of course inside of both P and Q. Why? Because in the situation V1, which corresponds to the first row of the truth table, P or Q is true. Same for V2, corresponding to the 2nd row of the truth table, and V3 corresponding to the 3rd row of the truth table. V4 is not shaded, or the region containing V4 is not shaded, because P or Q is false in that region. And we can visualize other propositions in a similar fashion. P and Q, we're going to shade the region containing the row or the situation that makes P and Q true. And there's only one, so we're going to shade the region containing V1. Not P corresponds to everything outside of P. So we're going to shade the region containing all the rows of the truth table that make not P true. So those are all the rows of the truth table that make P false. Now, an important use of Venn diagrams is to help visualize interesting relationships between different propositions or different formulas. So here's a fact. So not P or not Q is equivalent, tautologically equivalent, to not P and Q. Another way to say that is that this biconditional is a tautology. And yet a third way to say that is that these two arguments are valid. So the first argument has this first formula here, not P or Q, as its premise, and the second formula here as its conclusion. So that's a valid argument. In addition, if we take the second formula, not P or Q as a premise, not P and Q as a premise, and the first formula, not P or Q, as a conclusion, then that's also a valid argument. Now, we can see that very easily by looking at a truth table. So here in this truth table, since there are two atomic propositions, there are 4 rows to the truth table. And if we look at the truth values for our two formulas here, not P or Q and not P and Q, we see that in every row of the truth table, they have the same truth value. They're both false in row 1, and in rows 2 through 4, they're both true. So what I want to do now is show how I can use Venn diagrams to visualize this relationship. And the way I'm going to do that is I'm going to first start with not P or not Q. And we're going to think about the syntax tree for this formula. So the main connective here in this formula is a disjunction. So the syntax tree splits into the left disjunct, which is not P, and the right disjunct, which is not Q. Now, not P is just a negated formula. So the negated formula is in fact just P, and the negation of Q, the negated formula there, is just Q. So here we have the syntax tree for this formula, not P or not Q. But what I want to do is, using this syntax tree, I want to build up a visualization of this formula, not P or not Q. So I'm going to start by visualizing P. So again, I draw 2 circles with some overlap, and I'm going to shade the P region. So I shade all the ways in which P can be true. So that's why I'm shading this region right here. And similarly over here, I'm going to shade the Q region because I start with this Q proposition. So you can think of yourself as starting with P and starting with Q. I want to build up a visualization of not P or not Q. So the first thing I'm going to do is figure out, given this visualization, how do I visualize not Q? Well, I'm going to so here I've shaded the Q region. So since I'm taking the negation of that region, I shade everything outside of that region. So here I've shaded everything inside of this Q circle. Not Q corresponds to a shading of everything outside of that circle. And again, the shading represents all the ways in which not Q can be true. And we're going to do the same thing for P. So we've shaded the circle region where P is true, and we shade the region outside of the P region because that represents all the ways in which P can be false. So the last step is to combine these two visualizations into a visualization of not P or not Q. So you might want to take a second to think for yourself what this visualization should look like. So here's the answer. What we're going to do is we're going to shade the regions that are shaded in either of these two diagrams. So here we've shaded everything outside of P. So we should shade everything outside of P. And here we shade everything outside of the Q region. So that picks up the only thing that we haven't shaded, this little bit here, the bit inside of the P circle, but outside of the Q circle. But this is shaded over here, so we should go ahead and shade that. So the union is really, or the disjunction rather, is really a way of saying take the union of the two shadings. So here is a visualization of this proposition, not P or not Q, and you can see that I systematically built up that shading by looking at the syntax tree of this formula right here. So now let's do the same thing, but now for the formula not P and Q. So the main connective here is a negation. So I pull the negated formula down, it's P and Q. And so the main connective in this subformula is a conjunction. The left conjunct is P and the right conjunct is Q. So the first thing we're going to do is we're now going to take these two shaded regions and we're going to form the conjunction of these two shaded regions. So again, you want to think to yourself, what do you think should be shaded? So I'll have this Venn diagram, P and Q. So some part of this should be shaded and it should correspond to the conjunction. So what you're going to want to shade is the overlap of these two shaded regions. So if you look down to here, the only bit that is shaded in both of these regions right here is the part in which P and Q overlap. So the conjunction corresponds to an intersection of the shaded regions or to shade the regions that are common to both shadings. And then again, we already know how to deal with negation. Negation is, of course, going to shade everything that's not shaded in this Venn diagram right here. So to move to the negation, so here we have everything shaded inside of the P and Q region. So if we add a negation to that, we want to shade everything outside of this shaded region right here. So when we put these two constructions right next to each other, so here's the construction to form the shaded region for this formula right here, for not P or not Q. And here's the construction for the formula not P and Q. We see that these two formulas, we can sort of quickly see visually that these two formulas must express the same proposition, meaning that they must be true in exactly the same situations, because you end up shading exactly the same regions of the Venn diagram that corresponding to these two formulas. So let's look at another quick example just to see how this process actually works. So let's consider the formula not P and not Q and compare that to the formula not P or Q. So what we're going to do is we're going to start with this formula right here, not P and not Q. And we're going to start by visualizing P and Q. So there's two circles, one corresponding to P. So the one on the left here will correspond to P and the one on the right will correspond to Q. I'm not going to draw the P and Q every single time just to save a bit of time. And we're going to start with, again, P and Q. And I'll use blue to shade the P region. So P will be used, I'll use blue for P. And for Q, I'll use red. So there I've shaded the P and the Q regions. So looking at the syntax tree of this formula right here, we see the first thing we're going to do is we're going to form not P. So now, and not Q. So now I want to look at the not P region given this shade. So I've shaded inside of this one circle right here. So to shade not P, I'm going to shade everything outside of the P circle. So I'll use green for that. So there's everything outside of the not P region. And what about for not Q? Well, now not Q, I want to shade everything outside of this red region. So that's everything that is here. So everything out of, oops, sorry, I made a mistake there. So we want everything outside of this red region. So I want everything outside of the Q region. Okay. So now we have not P and we have not Q, and I want to form their conjunction. So I want to shade only the regions in which there's overlap. So let's look inside of this circle right here. This is not shaded over here. It is shaded over here. There are essentially four regions we want to look at. We want to look at the region outside of the circles, inside of this circle, so this region, this region, this region, and that region. All right, so let's do this systematically. So first of all, the region outside of the circles, that's shaded in both diagrams. So I should go ahead and shade it in the common diagram. What about the region that's in P but not in Q? So right here. Well, it's not shaded here in the left diagram, so I shouldn't shade it over here. What about the region in which they overlap? That's not shaded in either of the diagrams here. And what about the region that's in Q but not in P? Well, that's not shaded in the right diagram. Okay, so the shading is this region right here. So now let's do the same thing for not P or Q. So again, I'll draw my Venn diagrams for P and Q, and I'll use blue for the P region and red for the Q region. And now the first thing I want to do, so we're going to form the disjunction of P and Q. So we're going to form P or Q, and I want to know, well, what regions should I shade in P or Q? Well, again, there's 4 regions, and I should shade the region if it's shaded in at least one of the diagrams below. Well, let's look. Outside of the 2 circles, is this shaded down here? Well, it's not shaded in either of the diagrams, so I'm not going to shade it here. What about this part of the circle? So this part that's in P but not in Q. Well, yeah, we can see that that's shaded in the left diagram, so I should go ahead and shade it. What about the overlap region? That's shaded actually in both diagrams, so I should go ahead and shade it. And similarly, what about the region that's in Q but not in P? That's shaded in the right diagram, so I should go ahead and shade it. And now I need to take the negation of this region. So what is that? Well, I need to shade every region that's not shaded in this diagram right here. Well, the only bit that's shaded is everything that's inside of these 2 circles, so I need to shade everything outside of these 2 circles. And again, now we see that we end up shading exactly the same regions. Since we ended up shading exactly the same regions when we constructed these 2 formulas, these formulas must be logically equivalent, or the biconditional here is a tautology.